Okay, so let's discuss intermolecular forces of attraction, solids, and liquids. No? Although basics lang yun sa solids. No? Sige. So let's proceed with this idea muna. No? So before we understand the intermolecular forces, we have to understand first the kinetic molecular model of matter. No? So ano po meron sa kinetic molecular model of matter? Ito lang yon. So I'm sure you are very much familiar with this illustration since ito yung ginagamit since elementary, di ba? So sabi natin sa elementary days natin that yung solid, the particles are close together. Yung liquid, medyo may spaces, may space sila onte. And yung gases, yung particles ay hiwa-hiwalay, no? So, totoo naman, no? If you check the molecular construction of solid liquids and gases, makita mo na ganyan sila, no? May separation yung mga particles natin, no? So, the more separated your particles is, the more likely you will observe gases, no? So, kapag makikita mong hiwa-hiwalay yung particles, gas yon. Pag sinabi naman na yung particles ay dikit-dikit, pwedeng liquid yon, pwedeng solid, no? So, yun lang yung idea ng kinetic molecular theory of matter, no? Na yung particles, kapag hiwa-hiwalay, gases yon. Pag medyo dikit-dikit, liquid o kaya solid, no? Pero ito yung tanong, no? Bakit ang particles na matter humihiwa-hiwalay at bakit sila nagdidikit-dikit, no? So, yun yung siguro question sa atin. Kasi nung elementary tayo, okay na tayo dyan sa ganyang illustration. However, we have to explain why. Bakit ganito? Okay. So, to understand that, no, punta tayo dito sa table. No? So, dito natin makikita yung mga properties ng matter at different phases. No? So, tapos na tayo. No? Yung number 1, particles, atoms, or molecules lang yung mga nandyan. No? So, sila yung mga pwedeng hiwa-hiwalay. Pwedeng sila yun, dikit-dikit. No? Okay. So, punta tayo sa next property. Energy and movement of particles. No? So, according dito, matter that exist as solid have low energies. No? Mababa yung energy nila. So, ano meron kapag mababa yung energy nila, fixed yung location nila, fixed yung position nila. However, pag yan ay naging liquid, mas more energetic siya than solid, no? Pero pag yan ay naging gas, the particles have high energy. So imagine nyo na lang yung energy as ganito, no? So if ang solid, ang energy nila ay mababa, that means the particles are not moving. Fixed yung particles natin. Okay? So itong particle na yan, di yan gumagalaw. So andyan yan, steady yan. No? However, if it starts moving, pag gumagalaw na yan, ano mangyayari sa particles? They will separate. No? Pag gumalaw yan, maghihiwa-hiwalay sila. No? So magkakaroon tayo ng phase change, no? From solid to liquid, no? So ano ulit yung konsepto ng phase change? Yung particles mo maghihiwalay lang, no? So as your particles separate from one another, no? Pag naghihiwalay sila, they create gaps, no? So naghihiwalay sila, and as a result, they transition into the liquid phase, no? So nagiging liquid sila. Pero, giving more energy to your matter, ibig sabihin nun, mas magiging malikot sila, no? They will move more, no? So, if the particles move more because they have higher energy, what will happen is that the particles will be distant to one another na, no? So, the higher the energy, the more distant the particle becomes, no? So, as a result, magiging gas sila, no? Kasi yung gas particles, alam natin, hiwa-hiwalay sila, no? And that's the concept of phase changes, no? So, kung napapansin nyo sa refrigerator, yung yellow, di ba, na yung yellow nasa loob lang, di ba? Pag nilabas mo yan, what happens? Yung yellow ay natutunaw. Pag yung tubig, pinakuluan mo, nagbabubbles, no? So, ano yung relation yun dito sa kinetic molecular theory of matter, no? Kasi ganito. Remember na yung energy that can be translated into kinetic energy. Kaya nga kinetic molecular theory, no? Kaya may word na kinetic meaning may gumagalaw, no? So yung energy sa paligid na naa-absorb ng matter nyo, for example, yung yellow, that causes the particles to move, no? And as they move, nagkakaroon ng phase change, no? So kunwari, yung yellow nilagay mo sa labas. Kunwari, syempre Pilipinas to, 20, let's say 33 degrees Celsius sa paligid, no? So yung init ng paligid, i-absorb yon ng water molecules, no? So as the water molecules absorb the energy from the surroundings, magkakaroon sila ng kinetic energy, no? Matatranslate ang heat energy into kinetic energy. And with that translation, since naging kinetic energy na yung init sa paligid, ang particles mo ay gagalaw na, no? And as they move, they transition from solid to liquid, no? The same is true when you boil water, no? So for example, you have liquids, no? And you want to boil it off, no? Gusto mo maging gas siya. Ano gagawin mo? Ilalagay mo siya sa takore, ilalagay mo sa kalan, 'di ba? O kaya kunwari may electric heater ka, no? So anong ginagawa doon? The energy is supplied to water, no? So nagbibigay ka ng energy sa water mo. And as a result, the water molecules will get more excited. Mas lalo silang gagalaw, no? As a result also nun, mag-iiwa-hiwalay na yung particles. So there will be phase change, no? So ibig sabihin, the phases of matter depends on the energy, no? So the lower the energy, most likely you will observe liquid or solids, no? Solids being the lowest energy of all, no? Pag mataas ang energy ng particles mo, you will observe liquids or gases na mabubuo, no? Paano naman po yung concept ng pag-freeze ng yelo? Okay. When it comes to freezing, kunwari sa refrigerator, mas malamig ang surrounding kaysa sa yelo. Ay, mas malamig ang surrounding kaysa sa tubig na nilagay mo. So what will happen is that the heat will be transferred from your system mula sa yelo, mula sa tubig. Yung init ng water ninyo, matatransfer siya sa surroundings, no? So, as that happens, the energy of your particles will be lost, no? Kunwari ako, ilagay ko sarili ko sa freezer. Ano mangyayari sa akin? Yung energy ko mapupunta sa paligid kasi mas malamig yung paligid kaysa sa akin, no? So, matatransfer yung energy ko papunta sa surroundings. And as a result, there will be a loss of energy, no? Mababawasan yung energy ng matter natin. So, ganun din nangyayari, for example, sa water, no? Nari, liquid yan. Nilagay mo sa freezer. So, the refrigerator will absorb all the heat from the liquid, no? And as it absorbs the heat from the liquid, yung liquid ay nagiging mababa ang energy. So, since bumababa yung energy ng ating matter, what will happen is that they will freeze out, no? Magiging sila, fix yung position nila kasi malamig na, hindi na sila makagalaw. So magiging fix na yung position nila, so they will form the ice, no? Magiging solid na sila. Sa gases, ganun din, no? For example, sa atmosphere natin, no? So in the atmosphere, we have a lot of water vapor, no? At higher altitudes, no, yung temperature doon ay mababa, no? Usually around 3 degrees Celsius or 0, no? Ngari, pumunta ka sa 10 kilometers above from the Earth's surface, no? Sa atmosphere, mababa yung temperature doon. So as a result, the water vapor in the atmosphere condenses into liquids or solids, no? So kapag yung water vapor nag-condense into liquid, no? Kasi mababa temperature. So, ano mangyayari sa particles? Bababa yung energy nila. So, magsasama-sama sila. They will form the liquid, no? Itong liquid na to, ito yung ulan, no? Pero, the lower the energy is, or the lower the temperature is, mas lalong magdidikit yung particles mo, forming the snow, no? So, magiging snow yung liquid sa atmosphere, no? So, ito yung kapag ulan lang, ito yung kapag snow, no? Masyadong malamig. So, the water vapor will crystallize para maging solid, no? So, ano uli yung idea ng phase changes, no? Bakit nag-i-exist ang iba't ibang phase? Because of the kinetic molecular theory of matter. Ang sabi doon, the higher the energy of your particles, the more excited they are. Ibig sabihin ng excited, mas lalo silang gumagalaw. So the particles are moving faster, no? The faster they move, the more distant they become to one another, no? So kapag gumagalaw sila, mas lalo silang lumalayo sa isa't isa. And as a result, magkakaroon tayo ng phase change from solid to liquid, then to gas, no? Pero if you want to do the opposite, no? Gusto mo babaan yung energy niya, ilagay mo siya sa freezer or babaan mo yung temperature. As that happens, yung energy ng particles will be absorbed by the surroundings, no? Ilalabas ng matter yung energy niya. So, ibig sabihin nun, humihina siya, no? Bumabagal yung kanyang energy, yung kanyang kilos. So, pag bumabagal ang kanyang kilos, the particles will clump together to form liquids and eventually solids, no? So, ganun lang yung idea ng phase changes natin, no? So, yan. Yun yung kinetic molecular theory of matter. So yan, the faster the particle becomes, the more distant they are to one another, then magkakaroon tayo ng liquids or gases. Imagine nyo na lang yan as tao, no? Di ba kapag mainit, ayaw natin tabi-tabi tayo. Gusto natin may separation. Di ba? Pero kapag malamig, gusto natin magkakadikit tayo, no? So for example, ako, yung unan ko, niyayakap ko kapag malamig. Pero kapag mainit yan, hindi ako nag-uunan talaga, no? Nilalayo ko yung mga unan ko. Kasi mainit, no? So parang ganun, parang ako yung matter, no? So the higher the temperature, the more distant I am from my pillows, no? So yun, yung apat na unang ko, tatadyakan ko yan. Yung mga ganun, no? Pero kapag malamig, yayakapin ko yung mga yan, no? Para may, para may, parang, ang tawag doon? Basta yun, no? Para ma-insulate ka niya from the coldness sa paligid, no? So, ganun lang yung matter din natin, no? So, kapag mainit, lumalayo-layo. Pag malamig, nagdidikit-dikit, no? So, yan. Nasagot na natin yung isang question about the phases of matter, why they exist, at bakit may phase changes, no? It has something to do with the energy lang, no? Okay. But ito, ganito. Bakit kaya sila nag-e-exist as ganyan? Sabi na, ang na-explain natin ay they exist as that because of the energies, no? So, depending on the energy, pwede magsama-sama sila, pwedeng maghiwa-hiwalay. Pero ito yung next question natin. Bakit sila nagsasama-sama at naghihiwa-hiwalay? Okay, so yun yung sunod na question natin. Kanina, ano yung tanong natin kanina? Bakit sila naghihiwa-hiwalay at nagsasama-sama? So, isang sagot doon ay energy. Ulitin natin uli yung tanong. Bakit uli sila nagsasama-sama at bakit sila naghihiwa-hiwalay, no? So, kumbaga, another answer na naman to doon sa question na yan, no? So, the other answer for that, kung bakit sila sama-sama and bakit sila hiwa-hiwalay is ito. Attractive forces between particles, na. So, isipin nyo na lang to as ganito. Kunwari kayo, may mga jowa kayo, no? Ako, wala. So, hindi ko alam yung feeling. Hindi, joke lang. So, kunwari kayo, may mga jowa kayo, no? So, kapag attracted kayo sa jowa nyo, parang gusto nyo close kayo together, no? Gusto nyo magkasama kayo parate. Pero kapag hindi ka attracted sa tao, ayaw mo siya kasama. So, balik ulit tayo dito sa illustration natin. Sino kaya dyan yung feel nila na sama-sama sila? Ang obvious answer will be solid and liquid, no? Kasi magkakadikit sila, no? Pero yung gases, hindi sila magkakasama. Ayaw nila. Bakit hindi sila attracted sa isa't isa? hindi gaano, no? Kumbaga, etong solid, ito yung super duper close na friend, no? Kaya nga 'di ba kapag may mga super close na tropa, ang tawag doon solid na pagkakaibigan. Ito kasi yung explanation nun. Solid kasi mataas ang attractive forces, no? Biglang na ganun eh, no? So solid yung ating samahan kasi attracted kayo sa isa't isa, no? Pwedeng as friends, pwedeng as magjowa, no? Or kung ano pa man na nagbabind sa inyo, no? Pero kapag hindi kayo attracted masyado sa isa't isa, then medyo didistansya ka, 'di ba? So medyo hihiwalay ka. So yan. So medyo mababa yung attraction ng liquids. Kumbaga, ito yung super close friends, ito yung acquaintance, no? Acquaintance yung mga yung random lang na nakakausap nyo tapos di nyo napapansinin uli, no? Marami akong ganun eh. Tapos gases, ito naman yung ayaw mo talaga, no? Ayaw mo talaga kausapin, no? Hindi naman sa galit kayo, pero hindi kayo kasi match talaga, no? Kumbaga sa classroom, may ganito kayo, for sure. Kasi ako may classmate ako na ganun eh. Hindi ko talaga siya gusto ko usapin. Kaya lumalayo ako, no? Gas lang kami, no? Pero yung mga super close friends ko, ayun, solid kami, no? So ito, mga acquaintance, liquid lang, tamang daan lang, di ba? So, ganun. Kakausapin mo lang pag napadaan sa hallway or nakasalubong mo, uy, tamang plastic lang. No? So, ganun yung attractive forces. Ganun yung concept niya. No? So, for solids, ang attractive forces nila ay very strong. No? So, masyadong malakas yung attraction nila. That's why the particles are close to. Pag liquids naman, yung particles medyo may distance because may weaker forces, no? Weaker forces than in solids but stronger than in gases, no? Kumbaga siya yung in between, acquaintance nga, no? So yun. So yun yung mga particles na sakto lang, no? Pag tinanong yung friendship nyo, sakto lang. So hindi ganun kalakas yung attraction, pero hindi rin naman ganun kahina yung attraction. Okay? Tapos yung gases natin, masyadong mababa yung attractive forces nila. No? So, weak yung kanilang attractive forces. So, you won't expect them to come together. Maghihiwalay-hiwalay talaga sila. No? So, yun yung reason bakit tayo may iba't ibang phases. No? Number one is the energy. The higher the energy, the more energetic the particle is, mas mabilis ang kanilang galaw. The more kinetic energy they possess, ibig sabihin nun, mas maghihiwa-hiwalay sila. So, may tatlong phase tayo nun. No? So, ito, mga mababa energy, hindi gumagalaw. Liquids, medyo may energy, medyo gumagalaw. Gases, malakas yung energy, so hiwa-hiwalay. No? Another explanation for the phases of matter is the attraction. Kapag masyadong malakas yung attraction nila, you will expect solids. Pag hindi naman ganun kalakas, pero sakto lang, liquids yon. But if ang attraction ay super baba, no, they don't like each other that much, gases yon. Okay. So ngayon, pupunta tayo ngayon sa attractive forces, no? Ano ba yung attractive forces sa mga atoms and molecules, no? Kasi alam na natin, no, gets na po yung phase changes, no. So affected 'yan by energy and attractive forces. Pero ano yung attractive forces, no? 'Yun yung pupuntahan natin, no. Anyway, so punta tayo, forces of attraction tayo. So may dalawang uri ng forces of attraction, no. In chemistry, we have two types of attractive forces. Sana 'yon? Ayan. So we have the intramolecular forces and the palitan ko ng color. And we have the intermolecular forces na. So may dalawang uri ng attraction sa ating atoms and molecules. We have intramolecular and intermolecular. Isa-isahin natin yan. So when we say intra, parang yung intramuros, intramurals, diba? Ano meron kapag intrams, no? Sa university, pag intrams, lahat ng students, no, lahat ng mga players sa isang university, sila yung naglalaban-laban, 'di ba? So intramurals, no? Kumbaga sa loob ng university, doon naglalaban-laban. Intramuros, no? That is a Spanish term, no? Intra meaning within, muros is walls, no? Walls ang muros, intra ay within. Kaya ang tawag sa intramuros ay city within the walls, no? So yun yung Maynila daw. So ibig sabihin nito, intramolecular, meaning lang yan ay nasa molecule, within the molecule. So ito yung mga forces of attraction that joins the atoms together within a molecule. So ito yung mga ito yung mga puwersa that joins the atoms to create molecules. And ano ba yung mga forces of attraction na yon that holds the atoms to make molecules? Dalawa yan, di ba? Actually, tatlo, no? Mamaya, tignan natin. So ito yung mga intramolecular forces natin. Yun yung mga types of chemical bonds, no? Okay, so again, pag intra within the molecule, we are pertaining to the bonds. No? So itong bond na yan between this atom and this atom creating this molecule, we call that bond the intramolecular attraction. O yung inter naman, bago tayo dumiretso doon. Inter, ano meaning ng inter? Internet, no? Kapag internet, that is a connection of different networks. Intermolecular, connection ng different molecules. No? For example, this molecule and that molecule and this other molecule, may attraction sila. No? So we call that the intermolecular forces of attraction. So anyway, let's go muna sa intramolecular force. No? The forces that hold the atoms in a molecule. So the first type of intramolecular forces of attraction is ionic bond. No? So what is an ionic bond? We know that ions are created when atoms loses or gain electrons. No? Why do they lose and gain electrons? Because they want to be stable. So as they reach the stability, may electrons na malilipat talaga or tatanggapin. No? So bakit nagbibigayan ng electron? Bakit nagtatanggapan ng electron? Kasi they want to imitate the noble gas configuration. So, yun. So ano lang yan, no? Reminder lang. Kasi yun yung meaning ng ionic bond, no? So, your metals will lose electron. Your non-metals will gain the lost electron. Kukunin niya yung electron na nilabas ni sodium. And as they do so, they imitate the noble gas configuration. No? So, pag binigay niya yon, magiging noble gas configuration na siya. At the same time, they will be charged particles. No? So, magiging positively charged yung metal, magiging negatively charged ang non-metal. No? The attraction between the positive and the negative charged particles are caused by electrostatic forces. No? So, yung attraction between positive and negative charges are caused by electrostatic forces. No? So, ito yung puwersa that joins the positive and the negative ions. No? So, magsasama sila just like magnets. No? That's ionic bond. No? So, yan yung isang uri ng intramolecular force of attraction. Let's proceed with the next one. So, ang next one is that kung walang willing magbigay, mayroong mag-share. Okay, kung walang mag-give and take, mag-share na lang. Okay? So, that's covalent bond, no? So, covalent bond is a bond that is formed between atoms na mag-share ng electron in order for them to follow the octet rule, for them to be stable na. So, covalent bond yun. Okay? So, ano yung uri ng covalent bonds natin? So, we have two types of covalent bonds. No? So, we have a nonpolar covalent bond and a polar covalent bond. No? So, let's go with the nonpolar covalent bond. No? So, nonpolar covalent bond, from the word itself, nonpolar, that means the electronegativity difference is not that big. No? They have similar electronegativities. No? Kung naaalala nyo yung table, yung graph pala, yung line graph, no? Makikita nyo doon kapag pinag-subtract nyo yung dalawang electronegativity, you will get a certain value, di ba? So if that's less than 0.4, nonpolar yan, no? Okay. So for nonpolar covalent bond, the atoms that are involved, no, in forming chemical bonds do not have huge difference sa electronegativity or similar yung kanilang electronegativity, no? So yan. So walang pull ng electron dito. Yun yung nonpolar. However, if we have polar covalent bond, that means there is a difference there is an observable difference between the electronegativities of the atom, no? Medyo mapapansin mo yung difference ng electronegativities, no? So as a result, ano mangyayari? The more electronegative atom will pull the electrons towards it, no? So for example, we have H and Cl, no? So hydrogen is 2.1, Cl is 3.0. So obtaining the difference, that's 0.9, which falls under the category of a polar covalent bond, no? So since there is a noticeable electronegativity difference, no? Medyo malaki yung difference ng kanilang electronegativity. What happens is that the more electronegative atom will pull the electron stronger. So hihilahin niya yung electrons papunta sa sarili niya, no? So Cl will pull the electrons towards itself while the hydrogen has nothing to do about it. Wala na siyang gagawin. So no choice siya. Mababa electronegativity niya. So hindi siya pwede manghila ng electron. So what happens here is nagkakaroon tayo ng disturbance in the electron distribution, no? Meron tayong disturbance in electron distribution. Okay, so since we have disturbance in electron distribution, we have what's called the dipole. Kakaroon tayo ng dipole, no? So ano po yung dipole uli, no? If you forgot, recall lang natin. So since yung chlorine, siya ay more electronegative than hydrogen, it will pull most of the electrons towards itself, no? Kunwari, yan yung electron cloud niya. Tapos yung kay hydrogen, onti na lang, no? Onti lang yung electron. So, yeah. So, what will happen is that Cl will pull most of the electrons in a molecule, no? So, hihilahin niya yung karamihan ng electrons. Since the electrons are confined in that certain region, sa isang side lang, that side will become the partial negative side, no? So, may partial negative side to. Bakit negative? Because electrons are negative. Bakit partial? Because there is still a chemical bond, no? If you break that chemical bond, hindi yan covalent bond. Magiging ionic bond yan. Okay? So, yung ionic bond, walang bond talaga yan, no? Actually, mali itong illustration yan. Walang bond between Na and Cl. They are just attracted to one another because of their charges. Pero walang chemical bond, no? Dito may bond, no? Between H and Cl. So, may bond pa rin dyan. So, partial ang charge, no? Pag naputol yung charge, yung bond na yan, hindi yan partial. Full yung charge niyan, okay? So, since may bond dyan, partial pa rin, andun yung electron, so negative, no? So, the opposite side of the molecule will be partial positive naman ngayon, no? So, the hydrogen, since onti lang yung electron sa paligid niya, it will be partial positive in charge, no? So, as a result, we have dipole, no? May dipole tayo. Positive, may negative. Okay? So, ganun lang. So, yun yung polar bond, no? And sabi ko, di ba tatlo yan, no? We have ionic, we have covalent. Ano yung isa? Next one is metallic. Ito yung hindi natin nakwento last time, no? So, what is a metallic bond, no? Metallic bond is the bonding between metals, no? Okay. So, metals yung mga nag-share ng electrons, no? Akala nyo yung nag-share ng electrons ay non-metal lang? No. Metals can also share electrons with other metals, no? So, ang tawag doon ay metallic bonding. So, isa siyang special type ng covalent bond, no? Covalent bond yan that only occurs between atoms of metals. So, doon lang siya nangyayari. Okay? Pero kapag puro non-metal yan, edi covalent bond lang yan. No? Pero kapag puro metal yan, metallic bonding na. So, paano po nabubuo yung metallic bonding? So, ganito lang. Ang keyword dito ay sea of electron. No? Okay, so ganito yung nangyayari. So, suppose you have your metal centers in here. Itong mga dark dark circles na may positive sa gitna. That's the nucleus of your metal atoms. No? And the green dots around it, no? Yung light na dots, they represent your valence electrons. No? Yung electrons on the outer shell of the metal. No? So, yan yun. What happens here is ganito. No? So, since walang gusto dyan, tumanggap ng electron. Remember, metals love to give off electron. Ayaw nila tumanggap, 'di ba? Kaya nga nagkaroon ng violation sa octet rule, 'di ba? Okay. So, yan. Ayaw ng metals ng electron. So, ang gagawin nila is that yung kada metal atoms, they will distribute the electrons around them. Ipapamigay nila yung electrons around them, making a sea of electron. Okay? So, yung electron, freely flowing yan between the nucleus of different metal atoms. So, yung electrons, dumadaloy-daloy yan. Paikot-ikot lang yan dyan. Okay? And yung flow ng electrons na yan, yung sea of electrons na yan, that is the reason why metals are held together. No? So, yung reason bakit sila nagsasama-sama. Ba't sila solid? No? Okay, so yun yung nangyayari. Bakit may metal na nag-exist? For example, itong microphone stand ko, metal to. So kumbaga, sa surface nito, may sea of electron dito. No? And that holds the metal atoms together. Okay, and this is also the reason why metals are conductive. Because on its surface, the electrons are freely flowing. Umiikot-ikot lang yung electron dyan. So for example, you introduce an electric current, no? Pwede yan mag-pass through, no? So kapag nag-pass through yung electron, so yung electron pwedeng dadaan yan sa dagat ng electron, mapupunta sa other side ng circuit, you have kuryente, no? So that's why metals are conductive because of the sea of electron, no? That is formed by the covalent bonds between metal atoms, no? Yung non-metals naman, hindi sila conductive. Bakit? No? They love to accept electrons. So, kumbaga, kung non-metal ito, kung ito ay non-metal, yung electron ay hindi tatagos sa other side. No? So, papasok lang siya, tapos walang lalabas sa kabila. So, ano yon? Non-conductive. No? No, hindi siya conductor. Insulator siya pag ganun. Pero kapag metal, that's a conductor. So, tatagos yung electricity from one end to the other end. No? So, may kuryente. Okay? So, yun yung mga uri ng intramolecular forces of attraction. So, ano uli yung mga uri ng intramolecular forces of attraction? We have ionic bond. We have ions held by electrostatic forces. Ionic bond yon. We have covalent bond, wherein your atoms are bonded together by sharing the electrons, no? So, pwedeng nonpolar yan, wherein the electron negativity difference is low, mababa lang. Kapag polar covalent bond, medyo malaki yung electron negativity difference, no? So, as a result, may disturbance ng electron causing the molecule to be dipole. So, kapag dipole, may partial charges ka. The most electronegative atom will have the partial negative and the least electronegative atom will have the partial positive. And the last intramolecular force is metallic bonding. So this is a covalent bond exclusive for metal atoms. No? Their valence electrons are moving around them in a sea of electron. No? So yan. So ito yung reason ba't sila nagsasama-sama. So, kumbaga, isipin nyo yung electrons para siyang rope, no? Parang rope na inikot-ikot nila sa sarili nila. So, yung rope na inikot-ikot nila sa sarili nila, that will flow through them, no? Dadalo yan sa paligid nila. And sama-sama yung metals. No? So, ganun yung metallic bonding. Okay? So, ganun lang. Then now, let's proceed with the relative strength of intramolecular forces. No? So, ito yung magpe-predict kung sino yung solid, sino yung liquid, sino yung gas. No? Kung gaano kalakas yung attraction, more likely, solid yan. No? Pag mababa yung attraction, most likely, gases yan. Okay, so let's have this table. No? So, to rank the relative strength of the intramolecular forces, number one, or the strongest, would be the metallic bonding. No? So, metallic bonds are the strongest type of bonds, no? Intramolecular bonds. So, yan yung pinakamalakas na uri ng bond. No? So, let's have, for example, iron. So, ang magiging basis ko dito ay melting point, no? So, the basis for ranking is the melting point, no? So, hanapin ko yung melting point ng iron. Okay, so the melting point of iron is 1538 degrees Celsius. Next one is ionic bond, no? So, hanapin ko muna yung info ko bago ko i-explain. Melting point. Yan, 801. H2O melting point 0 degrees Celsius. CH4 melting. Parang nakakaantok, no? Ang tahimik ng araw na to. But anyway, so ito yung ating gagawin, no? So to rank the relative strength of the intramolecular forces, I am going to use the idea of melting point. No? Bakit melting point? No? Kasi ganito. Tingin tayo dito. Isipin nyo na lang, no? Kapag malakas yung attraction nila, it would be harder for you to separate them. No? Parang paghiwalay yung mga particles. No? So, ang idea ng melting point is that is the energy required to make the particles to make the particles separate, no, from one another. So from rigid structure magiging liquid siya, no. From solid magiging liquid. So yun yung idea ng melting point. So the higher the melting point is, that means the stronger their attraction to one another. Mas malakas yung kapit nila sa isa't isa. So kapag mataas yung melting point, mahirap paghiwalayan kasi maraming energy yung kailangan para maging liquid, 'di ba? Pag mababa yung melting point, ibig sabihin yung attraction nila ay hindi malakas, no? So, madali sila mag-transition into liquid. So, mababa or weak ang intramolecular force na, no? So, yun yung idea bakit ang melting point ang ginamit ko. Pwede rin naman yung boiling point, no? So, the higher the melting point, the higher the boiling point, the stronger the forces of attraction is, no? So, balik ulit tayo dito. So, kung i-observe natin, ang general example natin would be iron for metal. Its melting point is 1,538 degrees Celsius. No? That's almost twice as the melting point of salt, no? NaCl, which is 801 degrees Celsius lang. Okay. So, yan. So, that means yung metallic bonding, yun yung strongest, no? Relatively. NaCl is the next strongest, no? Then followed by water. Ang melting point ng water ay 0 degrees Celsius. And lastly, ang methane, which is nonpolar covalent, no? Ang kanyang melting point ay negative 182 degrees Celsius, no? So yan. So yan yung ranking ng ating strength of intramolecular force on the basis of melting point now. So yan. So the higher the melting point, the stronger the intramolecular force of attraction. So mas mataas yung attraction nila sa isa't isa, no? So ganun lang. Although may exemptions dito, of course. No? So ano mga exemptions? General naman kasi to, no? Kaya nga relative yan nilagay dyan. So, ano yung mga typical exemptions dito? Number one is mercury. Mercury exists as liquid under normal temperature. So, hindi siya solid na. So, mababa kasi yung lattice energy ng Mercury, kaya ganun na. So, anyway. So, yun lang yung idea na mababa lang yung energy, yung strength ng attraction ng Mercury metals, kaya liquid sila under normal condition. Ano pa yung liquid na metal? Gallium. Lobat pala yung laptop. Wait lang. Okay. So, yung gallium, pag nilagay mo yun sa palad mo, it will melt, no? So, yan. Yan yung mga exemptions, no? So, another exemption would be, sa non-polar, pwedeng yung diamond, no? So, yung diamond, solid yon kahit non-polar bond yan. Although, exemption yon kasi hindi naman lahat, no? Ganun nangyayari. In general, weakest pa rin talaga yan, no? May exemptions lang talaga. No? So, kumbaga, may mga special lang. Although, hindi naman marami yung ganun eh. Okay? So, generally speaking, ito yung susundin nating ranking. No? So, kung mapapansin nyo, the stronger the bond is, the more likely na solid sila. No? So, yan, mga solid yan. Ito usually liquid. No? And ito usually gases. No? So, depending on the type of bond na meron ka, you can predict kung sino yung solid, sino yung liquid, sino yung gas. Okay? So, ganun lang. Tignan mo lang yung molecule. Ay, ito solid to. Ito liquid to. Ito gas to. So, ano yung basis mo? Yung type of bond. No? So, ganun lang. So, you can predict the type of bond using, you can predict the phase of matter pala using the types of bond. No? So, and recall nyo na lang yung mga pinagsasabi ko kanina. No? By the way, itong PDF naka-upload na to sa Canvas. No? So, I uploaded it last September 30 pa. Pakita ko lang uli. Ang gloomy ng afternoon na to, no? Parang nakakaantok. So, ito yung PDF, no? Chapter 11 yung ginamit ka. Ay, hindi. Itong chapter 9. So, download nyo na lang yan, ha? Andyan lahat ng mga babasahin natin. Okay. So, yun lang. So, that's the intramolecular forces of attraction. Next one, let's proceed with the intermolecular forces. Again, one molecule to the other molecule. So, we are not pertaining to chemical bonds. No? Hindi na to chemical bonds. Inter na kasi. One molecule to the other molecule. Okay? So, for intermolecular forces of attraction, tatlo lang yan. No? So, these are the types of intermolecular forces that exist between molecules. Number one is the dipole-dipole interaction. From the word itself, ano yung nag-i-interact? May dipole at may dipole. So, ganun lang. That's the interaction between a dipole molecule, a polar molecule, and another dipole molecule, another polar molecule. No? So, how they are attracted ba? Tignan nyo yung ating polar molecule. Ano meron sa kanila? May positive, may negative. Okay? So, hindi lang naman itong molecule na to yung may positive at may negative. Maraming ganyan, no? So, let's have, for example, ito. So, kunwari, ito yung isang molecule. This is the partial positive. This is the partial negative. Tapos, ito pa yung isang molecule. May partial positive, may partial negative. Kasi yung isa pang molecule, may ganun din, no? So, ano mapapansin nyo? That the positive can be attracted to the negative end of the other molecule. So, itong positive end ng isang molecule, pwede ito kumabit, pwede siyang ma-attract sa negative end ng other molecule. Ganon din dito sa kabila, no? Itong negative end ng molecule na to, pwede itong ma-attract sa positive end ng other molecule. So, kumbaga, they are forming chains, no? So, yung chain na yon, nakahilera yung positives and negatives na. So, that interaction is called the dipole-dipole interaction. Na. So, nagkakabit-kabit sila para, yun, para magdugtong-dugtong, gumawa ng chain. Na. So, the interaction between this molecule and that molecule is dipole-dipole attraction or dipole-dipole interaction. Paano mo uli malalaman kung dipole yan? Check the dipole moment or the dipole. No? Tignan mo lang electronegativity difference. Kasi malalaman mo, uy, dipole to. Okay? So, ganun lang po. No? May notif yung Teams. Anyway. So, yan. Ay, nawala tuloy ako. So, basta yun yung idea ng dipole-dipole, ha? Yung positive end of one molecule will be attracted to the negative end of the other molecule and vice versa. No? So, yan. Dugtong-dugtong lang sila. Okay? So, yun yung dipole-dipole interaction. Next one is hydrogen bonding. So, sabi dito, that is a special kind of dipole-dipole interaction. Special siya na dipole-dipole. Bakit? Ito yung strongest dipole-dipole. Okay, so yun yung shortcut namin dito eh. Dipole-dipole, DD interactions. So siya yung strongest dipole-dipole interaction. Bakit, no? Mamaya kwentuhan natin yun, no? Based on experiment naman to eh, no? Kaya nasabi nila strongest. Oh. And what makes this special is that it can only be observed with OH bonds, NH bonds, and FH bonds. No? Can only be observed lang yan sa tatlong bonds na yan. So, dyan lang yan nakikita. Anything else, hindi siya hydrogen bonding. Okay? So, ano yung special sa kanya? So, ito kasing kanilang experimental analysis and yung interpretation nila. No? So, ganito daw. Remember, yung Earth, before its modern era, no? Bago tayo mabuo sa Earth na to, according to evolutionist, no? Yung mga nag-evolution, mga naniniwala doon, no? Sabi nila, the Earth is hot, no? The time na nag-collide yung moon sa Earth, no? That exposed the lava surface, the magma surface ng Earth, no? So, mainit ang mundo nun. Then, ganito daw, imagine mo na lang daw, if yung water sa Earth ay mababa ang boiling point, no? Ibig sabihin, mahina ang intermolecular force of attraction. Life would not be possible kapag ganun. Bakit? Una, mainit sa mundo, no? Yung temperature ng Earth usually around 90 degrees Celsius yan dati, no? 90, almost 100, no? Kasi exposed yung lava sa Earth, no? So if ang boiling point ng water or ang intermolecular force ng water ay mababa yung boiling point, so life would not be possible. Kasi 'di ba, if I don't know if familiar kayo no sa primordial soup, no. Sabi ng mga evolutionary people is that life began in the primordial soup, no. So the earth is just a wide ocean wherein nandun yung minerals, andun yung amino acids, no. Then nagsama-sama yon to form the cells, eventually life forms on earth, no. So yun yung idea ng primordial soup, no. And if ang hydrogen bonding daw ay hindi malakas, that means that primordial soup would most likely be evaporated. No? Mag-evaporate na lang yung water sa Earth kung hindi malakas yung hydrogen bonding. No? Kung hindi siya malakas na intermolecular force. No? So magbo-boil off yan, walang buhay sa Earth. No? That's why, kung mapapansin nyo, whenever na may discovery sa planet, na-excite sila about water presence. No? Kapag may presence daw ng water, ano inisip ng scientist? Baka may buhay doon. Bakit? No? Kasi nangyari yon sa atin sa Earth. No? Na yung buhay natin, naging possible yan because of the presence of hydrogen bonds in water. So, yun yung reason bakit yung scientists natin, they are so excited with water discovery sa Mars, sa moon, so on and so forth, no? Or the exoplanets. No? So, yun yung reason. No? Baka isipin nyo na, ano ba yan? Parang ano naman sila, tubig lang yun. Hindi, no? Yung tubig kasi, that can host life according to evolutionary people. No? Mga naniniwala sa evolution. So, pwede daw doon kasi magkaroon ng primordial soup. And who knows, no? Universe is too big, no? Kaya hindi natin masabi kung tayo lang nandito or may kasama tayo, no? But that's the idea, no? That's why sabi nila, hydrogen bonding is the strongest dipole-dipole kasi yun nga, mataas ang kanyang boiling point, no? Generally. So, mataas yung mga boiling point, so life became possible with hydrogen bonding. Actually, hindi lang sa water, even sa ating amino acids, no? Sa ating DNA. Remember your nucleotide bases, ACGT, no? Yung nasa DNA. They are paired, di ba? Naka-double strand yan, di ba? Stranded yan eh. Okay. So yung pairing ng ating amino acids, yung nucleotide bases natin, yung A, yung T, yung G and C, they are paired with hydrogen bonding as well. Yung ating mga amino acid, yung nucleotide bases na yon, may NH bond yon. So yung mga NH bond na yon, they can connect from one molecule to the other, forming the double strand of the DNA. Okay. So yun, kaya tayo may DNA, kaya tayo nag-exist, kaya tayo may kaya tayo may chromosomes dahil yun sa hydrogen bonding din, no? So the hydrogen bonding allows the pairing of one nucleotide base to the other through the NH bonds, no? So doon sila nagdudugtong-dugtong. Kaya life is possible with hydrogen bonding, no? Kaya ang tao na-excite talaga kapag may hydrogen bonding, no? Na na-observe sila sa planet na yon. Kasi yun nga yung reason ba tayo nabubuhay, no? Itong HF, acid lang yan, no? Hydrofluoric acid. So, yan. Malakas din kasi yung bonding ng HF daw. So, pero itong dalawa, ito yung pinaka-important siguro sa life, no? Ito acid to eh, masisira yung balat natin dyan, no? So anyway, so hydrogen bonding, this is the special type of dipole-dipole. So ganun pa rin yung concept, positive is attracted to negative. Pero ito yung strongest, no? Ito yung pinakamalakas na dipole-dipole. Next one is London Dispersion Forces or the van der Waals forces, no? Van der Waal basa dyan, no? German kasi siya, no? So ang V nagiging F, ang W nagiging V, no? 'Di ba Volkswagen sa iba. So sa Germany, that's Volkswagen. Volkswagen. Yung F nagiging, yung V nagiging F, yung W nagiging V, no? So that's van der Waals, Volkswagen, so on and so forth. Okay. So ano naman tong London Dispersion Forces, no? So the London Dispersion Forces or the van der Waals forces, this is the general intermolecular force of attraction. I will call it IMFA, no? Intermolecular Forces of Attraction. Ito yung pinaka-general. Lahat meron nito. Kesyo polar yan, kesyo dipole yan, kesyo non-dipole yan, no? Lahat yan meron, no? Even itong pencil na to, even itong kahoy na to, may mga London forces to. Bakit, no? So, ang usapan lang kasi sa London dispersion forces ay ang electrons, no? The more electrons, the stronger the London dispersion forces is, no? Okay? So, eto general to, lahat meron nito. Whether that's polar molecule, non-polar molecule, so on and so forth, lahat yan may London dispersion forces. Ano lang ba yung concept ng London dispersion? The concept is that kapag mas maraming electron, mas stronger ang London dispersion forces. Bakit, no? Siyempre, kailangan tinatanong natin, bakit? Okay. Sulat ko lang dito. More electron, higher London dispersion forces. Ang question, bakit, no? Bakit siya strong? So, let's have, for example, ano kaya? Cl2 na lang. So, gas tong Cl2, no? So, kunwari yung electron cloud yan ay circle lang. Bakit circle lang? Kasi, yan ay non-polar bond. So, walang disturbance sa electron cloud, no? So, yan. This is non-polar cloud. So, This is nonpolar bond, so the electron is evenly distributed. No? Pangit lang yung pagkakagawa ko ng circle. So, kunwari, this molecule collides with that molecule. Kunwari, nagbungguan sila. No? Kunwari, nagbungguan sila. Nagbungguan sila. What will happen? Ano yung meron dyan sa labas? Di ba may electrons dyan? Okay? So, itong electrons natin, at itong electrons niya, pare-parehas negative yan. So, what will happen to the electron clouds? So, kapag nagbungguan yung dalawang electron cloud, they will start repelling. Bakit? Kasi di ba kapag same charges nagre-repel, so ganun mangyayari dito, no? So, magre-repel yung kanilang electron clouds, no? So, yan. So, yan. So, di ba kanina evenly distributed? Ngayon, nag-repel na yung charges nila. So, itong side ng atom na to, onti yung electrons dito sa kabilang side, andun yung mga electrons. Ganun din dito, na ito yung side ng electron na onti yung electrons, na sa kabilang side yung maraming electron. That's because of the repulsion. No? And what happens when the electron is concentrated on one side? No? If the electrons are concentrated on one side of the molecule, nagkakaroon tayo ng partial negative and partial positive. No? Ganyan yung nangyayari sa London dispersion forces. No? So whenever the molecule bumps to each other, pag nagbubungguan sila, ano nangyayari? The electron clouds become distorted. No? So as they become distorted, no? Ano nangyayari? Nagkakaroon tayo ng dipoles. No? But mind you that those dipoles are temporary. No? So ano meron sa London dispersion forces? London dispersion forces. Meron tayo ditong temporary dipoles. No? So every time that the molecule or one molecule collides with the other molecule, every time lang na magbungguan sila, nagkakaroon ng dipoles. No? So ano pwede gawin ng mga dipole molecules na yan? Pwede sila gumawa ng dipole-dipole interaction. Okay? Pero again, the word is temporary. So ibig sabihin niyan, kapag lumayo na sila, mawawala na yung dipole. No? Kunwari, naghiwalay na sila. Kunwari, ayan, naghiwalay na sila. So the electron balance will be restored. No? So babalik na yan sa original. So kunwari, nagbungguan uli sila, di may dipole ka na naman. Tapos nawala na naman. Tapos pag nagbungguan uli yan, another dipole. So yun yung idea, no? That for London dispersion forces, you create temporary dipoles. But because that dipole is temporary, hence it is weak, no? Mahina yung London dispersion forces, no? Kaysa sa mga permanent dipoles, no? Okay, so temporary lang kasi to. So mabilisan lang. So quick lang siya. Tapos na. Kaya siya yung pinakamahinang intermolecular forces of attraction. Siya yung weakest because of this word, temporary dipole. Nag-email sa akin yung East-West. Wala naman akong credit card. Anyway, so yan yung idea ha. So London dispersion forces, you create temporary dipoles. So temporary lang siya, so weak yon, mahina yon compared to the permanent dipoles such as the dipole-dipole and the hydrogen bonding. No? So siya yung weakest force. No? And the more electrons you have, the higher the chances to create temporary dipoles. No? Higher number of electron, higher London dispersion forces. Bakit? No? Kasi kapag maraming electron, the electron cloud will be big. No? The bigger the cloud is, the more chances na magbungguan sila. No? So, yun lang yung idea ng London dispersion forces. No? Okay. So, let's summarize the intermolecular forces of attraction. So, in general, we have three. We have the dipole-dipole, hydrogen bonding, and London dispersion forces. No? So, dipole-dipole interactions occur between dipole molecules, partially charged molecules. No? Hydrogen bonding naman that exists, that occurs between dipoles Specifically, if they have hydrogen bonds, no? Ano yung mga hydrogen bonds? HF, HN, or HO, no? So yan yung mga yan yung mga hydrogen bond, no? And that is the strongest. Yan yung pinaka malakas, no? Okay, so yun. Then the last one is the London dispersion forces. This happens when there is a temporary dipole or induced dipole. Mabilisan lang. So siya yung weakest na. So, yun. So ano po nangyayari, no? Kapag meron tayong etong dalawa, if you have dipole-dipole and hydrogen bonding, most of the time sila ay liquid, no? Ito usually gases, no? Most of the time. Okay? Although may cases ng London dispersion forces na liquid, ano example nun? Mantika, no? So yung mantika, liquid yon, pero London dispersion forces lang meron doon. Bakit? Kasi yung electrons ng mantika, super duper dami, no? Around 300 electrons sa isang molecule. So, mas malakas yung kanilang attraction, no? So, magiging liquid yon, no? Okay. But in general, ganito yung itsura nila, no? So, magbibigay ako ng example na molecules, no? Na may kita natin yung difference, no? Ng strength nila. General lang to, kaya sabi dito, relative, no? It doesn't apply to all, no? Pero, yun lang. Just be minded lang. Okay? So, magbibigay ako ng example ng dipole-dipole attraction. Example would be acetone. Hanapin ko lang yung boiling point na lang, ha? Acetone. So, let me draw acetone. And water, H2O. Sana alam nyo pa yung lowest structures. Ano pa yung isa? Methane. Trigonal, planar. Trigonal, pyramidal. Ayan. We have acetone, water, and methane. Okay. So, ito yung boiling point nila. Boiling point na. Anyway, pwede namang boiling point, pwedeng melting point yung basis natin, no? Same lang naman yung concept, no? Kapag mahina yung attraction, mabilis mag-boil, mabilis mag-melt. Pag malakas yung attraction, matagal mag-boil, matagal mag-melt, no? So, let's have acetone, 56 degrees Celsius. Water, of course, 100 degrees Celsius. Ang methane, boiling point, negative 161.5 degrees Celsius. Okay. So these are some of the basic examples lang, no? The general examples, no? So yan. So what we can see here is that acetone is a dipole molecule. Why? Itong CH3, hindi yan dipole. I mean, nonpolar yan, no? Bakit? Yung carbon and hydrogen, similar sila ng electronegativity, no? Carbon is 2.4, 2.5 ata. Hydrogen is 2.1, no? So, non-polar bond yan. However, the C and the O bond, ito ay polar. Polar bond to. Okay? So, since polar bond yan, edi dipole yan. Okay? So, this molecule is dipole. Ang water, that is also dipole. However, ano yung special sa kanya? Hydrogen bond, no? May OH bond siya. OH, OH. Yung acetone, wala siyang hydrogen bond. Yes, may oxygen. Yes, may hydrogen. Pero ano yung requirement? Kailangan sila yung magkadugtong. Pag hindi sila magkadugtong, hindi yun hydrogen bond, ha? Keep in mind lang. Hindi hydrogen bond yun. Kapag yung oxygen hindi nakadugtong sa hydrogen, kailangan magkatabi sila. That also applies for fluorine and nitrogen. Okay? So, keep in mind lang. So, this is dipole, but not hydrogen bond. No? This is dipole and is hydrogen bond, no? Hydrogen bond yan. Ito naman, methane, non-polar bonds yan. So basically, non-polar molecule yan. Okay, so ano yung exhibit niyan? So hindi siya dipole, X na yan. Hindi rin siya hydrogen bond kasi hindi siya dipole, X yan. So ano yung pwedeng gawin ni methane? London dispersion forces na lang. Si acetone, dipole yan. Yes, so check dyan. Hydrogen bond, wala. London dispersion forces, pwede rin, no? Again, ang usapan kapag London dispersion forces ay electrons lang. Lahat ng atoms may electrons. So lahat may London dispersion forces, no? So ano meron dito? Si acetone ay may dipole-dipole. Meron din siyang London dispersion forces. Pero hindi siya hydrogen bond, no? So si water, tignan natin. Yan ay dipole-dipole. Yan ay may London dispersion forces. Kasi may electron, lahat naman may electron, di ba? And at the same time, yan ay hydrogen bond, no? Si methane, hindi siya dipole, no? Kasi yung bonds niya ay non-polar. So, hindi siya dipole, hindi rin siya hydrogen bond. So, what's left is London dispersion forces, no? So, tignan natin yung strongest na magagawa nila. So, for acetone, ang strongest ay dipole-dipole. For water, ang strongest ay H bond. Methane, no choice, LDF. So, yung kanilang intermolecular forces ba, does it show sa kanilang boiling point? Yes, no? Sabi natin, the stronger the intermolecular force, the higher the boiling point or the melting point, no? So, water here has a boiling point of 100 degrees Celsius kasi may hydrogen bond siya. Compare that to a dipole acetone, 56 lang, no? Halos half lang. Magbo-boil na siya. And of course, compare that to methane, no? Yung methane, hindi ka pa nagpapainit, naging gas na siya, nag-boil off na siya. Negative 161 degrees eh. So, masyadong mababa yung London dispersion forces. Okay? So, that's the example on how you predict the types of that's how you predict the phase of matter and the strength of the bonds na meron na. So anyway, so tapos na tayo sa first part ng discussion natin. So ganun lang. By this time, kailangan alam nyo na kung kailan dipole yung molecule, kailan siya non-polar, kailan siya polar. No? So just refer to the previous chapter that we discussed. No? Para ma-recall kayo. Okay? So just look at the molecule. Kapag may dipole yan, ibig sabihin dipole-dipole interaction yan, most likely. Pag may OH yan, may NH and may FH, may hydrogen bond yan. And lahat ng molecules, they exhibit London dispersion forces. Lahat yan. Kasi lahat may electron eh. Okay. Then to rank them, wait lang. Okay. And then to rank them, tignan mo lang kung ano yung strongest na intermolecular force na pwede nilang magawa na. Just refer to this graph na. Okay, water and acetone are liquid, no? Yung methane, gas yan, no? So, yan. So, yun yung proof na totoo yung ideas na pinagsasabi natin kanina. Although general yan, ha? Again, hindi porket general that applies to all. May exemptions, no? So, yan. Ano exemption? London dispersion forces ng mantika, no? Yung mantika kasi sobrang daming atoms nun, no? Around 20 atoms. 20 carbon atoms. And then, sandamukal na hydrogen atoms, no? Around 40. So, may mga oxygen pa, no? So, masyadong madaming electron. So, na-overpower niya yung ibang forces of attraction. But for the quiz proper, no? So, hindi naman ako magbibigay ng ganong example, no? Okay? And just look at the molecule. Check mo kung may dipole, kung may hydrogen bond, kung London, no? Then, saka ka mag-ranking, okay? So, yun lang naman yung task nyo dyan, eh. Okay? So, yan. So, we're done, no? So, tapos na tayo sa intramolecular and intermolecular, no? So, check naman natin to, no? So, let's check this one. How forces of attraction affect the properties, no? So, kung mapapansin nyo, ang intramolecular force is stronger than the inter, no? So keep in mind yan, no? Intramolecular is greater than or stronger than the inter. Mas malakas yung intramolecular forces rather than intermolecular forces. No? Kasi kapag intermolecular, ang ginagawa mo lang, pinaghihiwalay mo lang yung particles. Kapag intramolecular, yung atom sa molecule, yung paghihiwalayin mo. Mahirap yon kasi bonded sila. Unlike sa intermolecular, ano lang, infatuation lang. No? So may temporary attraction, madali lang tanggalin. No? Okay, so that's why intramolecular forces of attraction is generally stronger than inter. Okay? So ito yung ranking nila. So ionic bond, intramolecular yan. Then hydrogen bond, ito na yung intermolecular. Polar, ito yung intermolecular. Non-polar, ito yung intermolecular as well. No? So yan. Just refer to the table when ranking them. Na? Basta alam mo lang yung concept ng dipole, alam mo yung concept ng positive, attracted sa negative, so on and so forth. Na? Masasagutan nyo yung ranking. Okay? So yan. So I'm done with the first part of our lesson. Matatapos natin to ngayon. Don't worry. Wait lang. Mainit na eh. Okay. So let's proceed with the next one. Surface tension. I mean, the properties of liquids naman. So in liquids natin, what can you observe sa liquids? Di ba napapansin nyo, kunwari, uminom kayo sa baso. Yung liquid nagko-curve siya, di ba? So it could curve upwards, pwedeng downwards, depende sa surface na. So for example, meron kang Teflon, patakan mo yun ng tubig. Ano mangyari sa itsura ng water? Pabilog siya, no? Pa-circle. Ipatak mo yung tubig sa sa plastic, pakalat yung water, 'di ba? Or ipatak mo yung tubig sa balat mo, no? Sa daliri mo, kumakalat yung tubig, 'di ba? Compare that to Teflon. So ang question doon, bakit yung water nag-spread out? Bakit siya nag-spherical na? Okay, so let's discuss the properties of liquids this time. Now. So there are two properties of liquids that we have to consider. Number one is the surface tension. The other one is the viscosity. Now, so surface tension muna tayo. So for example, we have this water strider. Ito yung nasa movie ni Jackie Chan. I don't know if familiar kayo. Pero nung bata ako, grade 4 ata ako noon, year 2008, no? Grade 4 ako noon. Nanonood ako ng Jackie Chan movies eh. Yung sa isang DVD, maraming movie. So, yun. So, napanood ko si Jackie Chan and in-emphasize doon yung water strider. So, ganito yung itsura nun sa movie, no? So, this is the water strider. It walks on the water. No? Parang Jesus Christ lang. Pero mapapansin nyo, sa paa niya, yung liquid ay nagko-curve. Mapapansin nyo, may curvature ng liquid, no? Ang tanong, bakit, no? Ang sagot doon ay surface tension. So, when we say surface tension, the layman term for surface tension is the bending of water lang yan. No? Bending of liquid lang yan. So that is the bending of liquid in order to maximize the forces of attraction. No? So kumbaga nagbe-bend yung water para tabihan niya yung gusto niya or layuan niya yung ayaw niya. That's surface tension. The technical definition of surface tension, on the other hand, is this. No? That is the measure of the elastic force in the surface of a liquid. Surface tension. And surface tension is the amount of energy required to stretch or increase the surface of a liquid by a unit area. So basically, elastic force yan. Magbe-bend yung water. Okay. So bakit po nagbe-bend yung water? Ganito lang yung options. Pwedeng gusto niya yung katabi niya or hindi niya gusto yung katabi niya. Bakit nagbe-bend? Gusto niya yung katabi niya or ayaw niya yung katabi niya? In what sense po yung gusto or ayaw? No? Intermolecular force. No? If ang liquid natin have the similar intermolecular force with the other molecule sa katabi niya, pwede siya dumikit, pwede ring hindi. No? So let's have, for example, these two test tubes. No? So on the left side, we have water. On the right side, we have mercury. Okay, so on the left side, we have water here, which is dipole. And on the right side, we have mercury, which is metallic. No? Etong test tube na to, this is made of glass. No? And glass is a polar substance. Polar yung bonds diyan. Okay? So polar yung glass, polar yung water. Polar yung glass, metal ang mercury. Okay. So, ganito. Kailan po magiging gusto niya yung katabi niya? So, if the molecule have the same intermolecular force with the other molecule, no, or the other substance, magdidikit sila. So, they will join. So, let's have, for example, yung water. So, tignan mo, yung water, this is polar. Glass is polar. So, what happens here is that instead na yung water ay flat, dinidikitan niya yung sarili niya kay water. So, kumbaga, nagka-curve siya padikit kay water. Yan na. Yan yung curve na. So, hindi siya flat. Yung curve niya ay downwards, no? We call that the concave meniscus, no? So, nagka-curve yung water. Bakit? Gusto niya yung katabi niya. Polar ako, polar ka. Magsama tayo. So, magka-curve yung liquid, no? So, magka-curve siya in a concave fashion, no? So, makikita nyo yan sa baso. Tignan nyo yung gilid ng baso mamaya. Uy, naka-concave meniscus siya. May papansin mo yun sa pinakagilid. Naka-curve yung water upwards, no? So, dumidikit yung water pataas sa gilid ng glass, no? So, ganito yung idea, no? Flat yan dapat. Pero since gusto ni water yung glass, didikit siya sa kabila, no? Forming the concave meniscus. Kaya may ganyang curvature. So, flat yan, pero dumidikit siya sa tabi niya kasi gusto niya. Okay? So, ngayon, let's have mercury naman. So, mapapansin nyo sa mercury, anong curvature? Bulging, no? Pa-up, outwards. Ang tawag dyan sa bulge na yan ay convex meniscus, no? Bakit? Mercury is metal. Glass is polar. So, tingin nyo, magmamatch sila. Hindi. Kasi magkaiba sila ng attraction. Hindi nila gusto ang isa't isa. So, what will happen since they have the opposite or they don't have the same attraction, so Mercury, lalayo siya sa glass. Sabi niya, ayoko sa'yo. Hindi tayo talo. So, ang gagawin ng Mercury, magko-curve siya in this manner. So, hindi niya didikitan niya to. So, kukurba siya ng pagganito, forming a convex meniscus. Okay? So, yun yung reason why we have meniscus, no? Bakit uli may meniscus? Because of the attraction of liquids to the glass, no? Try nyo yan sa mantika, no? So, yung mantika, it forms a convex meniscus, no? Basta mag-ingat ka lang sa pag-drop, no? Kasi minsan pag kumalat yung mantika, baka maisip mo concave yun, no? Not really, no? May papansin mo yung naka-convex yun. Kapag dahan-dahan mong pinur yung mantika, no? Magpo-form yun ng convex meniscus, no? Okay, so yun lang yung idea. So, why we have meniscus? Dahil yun sa surface tension, no? So, ang tawag sa ginagawa ni water kapag dumidikit siya sa glass, we call that the adhesive forces, no? So, adhesive forces yon when your substance attaches to the other substance. Dumidikit siya sa kabila, no? So, adhesive, dumidikit sa sides. That's adhesive forces. Pero, kapag hindi siya dumidikit sa side ng glass, we call that the cohesive forces, no? So, adhesive, dumidikit, forming concave meniscus. Cohesive, ayaw dumikit, forming convex meniscus. Okay? So, yan. And the rising of water or the rising of liquid in a tube, no, due to adhesive forces, we call that the capillary action. So, ano yung capillary action? Capillary action. That is the rising of liquids. So, yan yung pagtaas ng liquid sa sides ng tube. No? For example, ito, mapapansin nyo, di ba umaakyat yung tubig pa punta sa gilid? So, that's capillary action. The rising of liquid sa gilid ng tubes. No? So, saan po iyan nakikita? No? Actually, the capillary nabulol na ako. The capillary action is the reason why plants have water. No? Imagine nyo yung puno, di ba sobrang taas? Alam natin may gravity, di ba? So, dapat yung water na pull down. Pero ano nangyayari? Hindi ganun, di ba? Yung water, tuloy-tuloy siya nga aakyat papunta sa taas ng puno. Pupunta siya sa dahon because of the capillary action. No? Malakas kasi yung attraction ng water sa bark ng kahoy, no? So, aakyat siya instead na bababa, no? So, aakyat yung water until ma-reach niya yung dahon. Okay. Saan pa nakikita yung capillary action? Sa capillary tubes, no? I don't know if nakapagpa-hospital na kayo. Capillary tube, blood. So, kapag nasa hospital kayo, may makikita kayong mga ganitong eksena, no? So, yan. So, ito yung blood. Yung manipis na tube na yan, that's capillary tube, no? So, ito yung itsura ng tube na yan. Ano ginagawa dyan? That is used to collect blood, no? So, gagawin dyan, yung tube, ididikit mo lang sa finger na may dugo. Then, what will happen is that the blood will eventually fill the volume of the tube, no? So, aakyat siya ng kusa, no? So, ganyan yung nangyari. Kunwari, idikit mo lang yan, aakyat agad yung blood papunta sa tube, no? So, that's one way for medical technologists, no, to collect blood samples, no? So, ano nangyayari dyan? That's capillary action due to adhesive forces of blood and the glass. Yung blood natin, polar yan. May water dyan eh. Okay? May water dyan, so polar yan. So, aakit yan because of adhesive forces. No? So, yung rising of water or liquid from the sa tube, no, within the tube, that's called the capillary action. Okay? So, yun lang. So, para pag nagpunta kayo ng hospital, tapos nakita mo, tumataas yung dugo, capillary action yan po. No? Ganon, no? Okay, so that's one liquid phenomena, no? So, that's surface tension, the curvature of liquids. Pag gusto niyo yung katabi niya, adhesive forces yung mangyayari. Aakyat yung water sa sides ng glass, no? Forming the concave meniscus. Pero pag ayaw niya yung katabi niya, it will not curve to the sides, no? Lalayo siya sa sides, forming the convex meniscus, no? Because of the cohesive forces, no? Also, kapag may thermometer ka sa bahay, please check, no? Check nyo kung yung meniscus ay concave or convex. Bakit? Yung thermometer kasi natin, dati may mercury yon. So kapag may mercury yon, what you can observe is that merong convex meniscus doon. May paganyang curve. So, pag nakita nyo yung thermometer nyo, naka-convex meniscus yun, kabahan kayo, no? Baka mercury yon. Kasi ano ba dapat? Concave, no? Kasi ang thermometer ngayon ay gawa sa alcohol na lang, no? Alcohol yung nasa loob na niya, hindi na mercury kasi toxic to eh. So, kapag alcohol thermometer yan, mapapansin mo yung concave meniscus. Pero kapag mercury yan, naka-convex meniscus yan. Okay? So, that's one use ng intermolecular force sa daily life, no? Isa yung sa capillary tube, pangalawa yung sa puno, pangatlo thermometer, no? So by just looking at the end of the liquid, you can judge kung siya ay mercury or siya ay alcohol, no? Kasi yung alcohol, adhesive yon. Polar ang alcohol, may hydrogen bond yon. OH yung alcohol eh. So ang ano naman, ang mercury, metal yon. So, hindi sila talo ng convex yan. Okay? So, yan. At least, alam nyo kung paano gamitin siya sa buhay, di ba? Okay. Next one, viscosity. Ito yung lapot, no? Bakit malapot yung mga bagay na malalapot, no? Bakit kaya malapot yung ganito, ganyan, no? So, maraming example sa buhay na malapot, merong hindi, no? For example, water and ano pa, arnibal. Kunwari, may taho, di ba? Bakit po malapot yung arnibal? kaysa sa tubig, no? Okay, so one way to answer that is via the intermolecular forces then, no? So let's have those two, no? By the way, bago tayo pumunta doon, viscosity is the resistance of fluid to flow. Ibig sabihin, if the fluid resists flow, ibig sabihin, mabagal siya dumaloy, aka malapot. Okay? Pag mababa yung viscosity, so ibig sabihin nun, ano ibig sabihin nun? Ibig sabihin nun, malapot yun, no? Okay? I mean, ganun nga. So, pag mababa yung viscosity, ibig sabihin mababa yung kanyang, ay hindi, baliktad pala. Kapag mataas ang viscosity, mataas ang resistance to flow. Hence, malapot siya, no? Compared sa mababa yung viscosity, no? Okay, so magbibigay ako ng two generic example. Yung tubig and asukal, no? So, let's have that. Water. Okay, so kailangan alam niyo yung geometries nila, no? Water is bent. Sugar. Kailangan. So, hindi ko alam kung anong sugar tong drawing ko, no? Pero ganyan yung itsura ng sugar. Okay. So, at each end, may carbon dyan. Carbon, 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 carbon. Tapos may hydrogens. So, that's sugar. So, ito water to. Okay. So, tignan natin. What are the intermolecular forces that the two can exhibit? So, ano pwede nila gawin, no? So, looking at water, may OH ka dito. So, dipole yan. At the same time, hydrogen bond, no? So, ilang hydrogen bond meron dyan? Isa, dalawa. Itong nasa left, itong nasa right, no? So, may 2 H bonds ka. Okay? For water. For sugar, ilang H bond meron dyan? Kasi may mga OH, no? So, bonded yan. Hydrogen bond yan. So, ilang H bond? 1, 1, 2, 3, 4, 5, no? So, you have 5 H bond. No? So, 5 H bond meron ka dyan. So, sino mas malapot? Water or sugar? Alam natin, sugar because arnibal, no? So, we know that sugar is more viscous. Mas malapot siya than water, no? Less viscous. Ba yung spelling na yun? Basta yan. So, sugar is more viscous than water, no? Hindi ganun kalapot yung water compared to sugar. Okay, so ano pwede natin ma-deduce out of the idea ng intermolecular force? Ang pwede natin masabi is that the higher the intermolecular forces of attraction, the higher the viscosity, no? So, ibig sabihin, the more intermolecular force, the more malapot, no? So, yun lang yung idea dyan, no? That's why sugar is mas malapot kaysa sa water. Okay. So, yun lang yung idea dyan, no? So, higher infra, higher viscosity. Okay. So, ganun lang. Well, let's have this one. So, these are the different hydrocarbons, no? Hexane, heptane, octane, nonane, decane. So, octane, ito yung nasa gasolina. Malapot yung gasolina, di ba? Hexane, parang tubig lang yan, no? So, ano yung nangyayari dito? So, as you can see, habang dumadami yung carbon atoms natin, from hexane to decane, ano nangyayari sa viscosity? Tumataas, no? So, this is 3.26 times 10 raised to negative 4. Sa decane, that's 1.42 times 10 raised to negative 3. Mas mataas. So, ibig sabihin nun, the higher the London forces lang mga to kasi nonpolar bonds yan, no? So, London forces yan lahat, no? So, the higher the London force, the higher the viscosity. Okay? So, the higher the London force, higher IMFA, higher viscosity, mas malapot, no? Pwede natin isama dito yung mantika, no? Mantika is non-polar. So, London dispersion forces lang yon. 'Di ba yung mantika malapot? No? Because of the higher London forces, no? Sobrang daming electrons ng mantika kasi, no? Around 200, 300. That's why super lapot niya, no? So, yan. So, yun lang idea. Higher IMFA, higher viscosity. Okay? So, those are the two liquid phenomena, no? Surface tension and viscosity. No? So, depending on the intermolecular force, you can have different surface tensions o kaya pwede yung different viscosities, no? So it's just a matter of looking at the molecule, identifying the types of bond na pwede nila gawin, no? Then you can deduce an idea sino mas malapot, sino hindi, sino yung mag-curve into a concave meniscus, sino yung sa convex, no? So ganun lang yung idea, no? Just a matter of comparison, no? So all the information are written here naman. So you can read them. No? Okay, so yun lang. So tapos na tayo sa liquids, na. Next one would be solids, no? So solids na tayo. Malapit na tayo matapos, guys. By the way, hindi na natin gagawin to, no? Hindi na tayo magaganyan-ganyan. Kasi ako napapagod na ako. Tsaka hindi ko na siya sinama. Para simple lang yung idea natin. Okay? Simple lang naman yung gusto natin dito. So, for solids, I will use the PowerPoint that I uploaded, no? Para may picture. Mas maraming picture dito eh. Nandun dito sa discussions, no? So, download nyo na lang. Ayan. So, let's have solids, na. So, may dalawang uri tayo ng solids, na. So, we have crystalline solids and we have amorphous solids, no? So, what's the difference between the two, no? So, crystalline solids are solids with long-range order, specific positions, rigid and long-range order. So, yun pa lang yung keyword, no? So, ang idea natin with crystalline solids is that yung particles niya ay arranged, no? Crystalline solids, particles are arranged properly, no? Ang amorphous solids naman, amorphous, sinusulat ko, nakasulat na nga, no? Para ma-emphasize ko lang. So, amorphous solids, ano sabi dito? Does not possess well-defined arrangement and long-range molecular order. No order. No arrangements. No. So, hindi maganda yung pagkakaayos ng molecules compared to crystalline. Ano epekto nun? Okay, ganito. So, when the molecules are properly arranged, ano mangyayari? The intermolecular force is high, no? So, mataas ang intermolecular forces kapag arrange ang matter. Pag arrange sila properly. So, what's the result? Eh di matibay yun, no? So, the more ordered your solid is, no? The more ordered the particles are, no? Sa isang solid, the higher intermolecular forces ang pwede. So, as a result, matibay ang solid na yun. So, let's have some example of crystalline solids. Yung mga nasa relo, no? Yung quartz. Ano pa? Yung nasa cellphone. Yung mga Corning Gorilla Glass, no? Mga ganong technology, no? Yung mga glass na ganon, mga matitibay, no? So, hindi agad sila nababasag-basag, no? So, crystalline solids yan because the particles are well arranged, no? And when the particles are well arranged, the intermolecular forces is strong. Malakas yung kapit nila sa isa't isa kasi naka-arrange sila, no? However, if their arrangement is not fixed, no? If hindi maganda yung arrangement nila, so pangit yung pagkakasalansan, so mababa yung intermolecular force. Hindi malakas yung kapit. Hence, marupok, no? Yun yung mga amorphous solids, mga marurupok, no? Example niyan would be your chalk, no? Chalk ay solid. However, pisilin mo lang yun, durog agad. Bakit? Kasi the particles are not arranged properly. So, hindi maganda yung arrangement niya, no? So, kalat-kalat yung particles ng calcium carbonate sa chalk, so mabilis yung masira, no? Another example ng amorphous solid would be yung baby powder, yung talc, no? Yung nasa makeup ng babae, no? So, ano pa ba? Yung baby powder, yung makeup ng babae, ano pa ba? Yung glass sa bintana natin, 'di ba? Isang hampas mo lang diyan, crack agad, no? Compare mo 'yan sa relo. Hampasin mo yung relo, hindi agad 'yan nagka-crack, 'di ba? Okay? Kasi yung glass ng relo, yun ay crystalline solids na. So matibay sila. Unlike amorphous solid, isang hampas mo lang, magka-crack agad. Bakit, no? Because mababa ang kanilang IMFA. Mababa yung intermolecular forces of attraction. Hence, mahina sila, marupok na. So, punta muna tayo sa crystalline solids. Ano po ba yung itsura nila? So, ganito lang naman na ganyan yung mga itsura ng crystalline solids natin. May order, may arrangement, may pattern, no? So, ito yung mga uri ng patterns na sinusunod nila. So, may simple cubic, body-centered, and face-centered, no? So, pag simple cubic, all the atoms are on the corner of a cube. Imaginary yan, no? Pag body-centered, you have the atoms at the corner of the cube and you have an atom inside the cube, no? Inside the imaginary cube. Pag face-centered yan, you have an imaginary cube and all its faces will also have one atom in there, no? So yan yung pattern na sinusundan nila, no? Okay, so ganyan yung mga itsura ng ng ating mga atoms, okay? So by the way, hindi na natin lalaliman 'yan kasi ang daming calculation na 'yan, like bulaga na. Wow. Wag na natin gawin 'yan. Okay? So, 'yan. So, yan, mapapansin nyo, all the crystalline solids are properly arranged, no? Kumbaga isipin nyo ito as parang ito. Para siya yung dalandan sa palengke, 'di ba? Yung dalandan sa palengke naka-properly stock yon. Kaya hindi agad nasisira, no, yung arrangement, di agad nauhulog. Kasi maayos yung pagkakasalansan ng particles. So, ganun din sa solids, no? When the particles are properly arranged, matibay yon. Pag hindi, marupok yon, amorphous. Okay? So, that's for crystalline solids. Ano yung mga uri ng crystalline solids natin? Number 1 is ionic crystals. So pag sinabing ionic crystals, these are crystalline solids with ions at the lattice point, no? So meaning ng lattice point, yun yung mga nasa edge ng cube, no? So yun yung mga nasa shape niya, no? Yan yung mga particles na nasa kanyang arrangement, no? So ionic crystals, ions ang nakalagay sa kanyang structure. Okay, so an example niyan, asin, no? NaCl. So, nito yung mga properties nila. They are held by electrostatic attraction kasi positive is attracted to negative. Hard, brittle, high melting point, no? So, yung asin, mahirap yung durugin. Brittle, medyo mahina, no? High melting point, so mataas melting point yan. Ang asin ay 850 plus degrees Celsius. Ay, hindi, 803 degrees Celsius pala. So, they are poor conductor of heat and electricity. No? So, ito mga side kwento na lang yan. No? So, again, ionic crystals. Ionic crystals are composed of ions. No? So, the next type of crystal na crystalline solid ay covalent crystals. No? So, kung kanina ions, ngayon naman ay atoms. No? So, ano yung mga properties nila? So, ganun din, matibay din. Malakas din yung kapit. Poor conductor of heat and electricity. Examples are diamond and graphite, no? Okay, so diamond, ano yan? Puro carbon atoms lang yan na matibay, na. So, ito yung kanyang arrangement, no? So, nakaganyan yung carbon sa diamond, no? So, graphite, ano example niyan? Carbon nanotubes, no? Mga carbon nanotubes, carbon fiber, no? Yung mga kulay itim na carbon fiber. So, yun. Puro carbon atoms lang yun. Covalent crystals tawag doon, no? So, naka-arrange sila ng ganyan, no? So, you have hexagons of carbons, no? At naka-flat sila. Nakapatong sila layer by layer, no? So, kaya matibay yan. Next type of crystal would be molecular crystals. So, kung kanina sa ionic you have your ions, for covalent you have your atoms, for molecular crystal you have your molecules, no? So, molecules naman yun nandito. Okay? So, they are held together by intermolecular forces kasi nga molecules na yan, no? So, pwedeng may dipole-dipole, pwedeng may hydrogen bond, pwedeng may London dispersion. So, soft siya and mababa yung melting point. For example, yung water, no? Yung yellow. Malambot yan kasi ginangat-ngat ko yan eh. Mababa din yung melting point niyan kasi magme-melt agad yan at 0 degrees, di ba? And they are also poor conductor of heat and electricity, no? So, yan yung ating molecular crystals. And the last one would be metallic crystals. Ito yung na-discuss natin kanina, no? So, yung mga sea of electrons, no? So, they are composed naman of metal atoms, no? So, they are held by metallic bonds, soft to hard, depende sa mangyayari, low to high melting point, and good conductors of heat and electricity. So, these are your nucleus, no? And ito yung mga electrons, no? Yan yung sea of electrons that hold the atoms together. Okay? Metallic crystals yan. Okay, so yan yung mga types ng crystals natin, no? Crystalline solids, ionic, covalent, molecular, and metallic, no? So basahin nyo na lang yan, no? Nasa PowerPoint naman. So next one is amorphous solids, no? So amorphous solids, ito yung mga marurupok, no? Sabi ko nga, yung chalk, yung baby powder, yung nasa makeup ng babae, so yun, yung milko, yan ay mga amorphous solids, no? So yan. So they do not possess arrangement, no? They do not possess well-defined arrangement and long-range molecular order. For example, on the left, babansin natin that the particles are well-arranged. So quartz yan. Crystalline solid yan. Pero tingnan mo tong kalat-kalat, no? So walang pattern, walang arrangement, no? So this is non-crystalline, no? So that's glass, no? So mabilis yung masira. Okay? So ganun lang. Yan. So depending on the arrangement of your particles, your solid can be strong, pwede ring hindi, no? Okay? So yun lang yung concept na gusto ko i-share dyan sa inyo. So saan ginagamit yung concept nitong crystalline na to? Ito mga crystalline solids, no, etc., etc. This ginagamit sila in creating superconductors. Mga ginagamit sa maglev trains, no, magnetic levitation trains, no. So it makes use of the crystalline structure of the atoms, no, para mag-float, no. Ang particle para mag-float yung objects, no, for transport, pwede rin for electricity purposes, etc., etc. No? So, yan. So, doon siya ginagamit, no? Solar panels din, no? So, solar panels, ginagamitan na lang ng concept ng crystals, no? Para yung electrons mag-jump, giving electricity, no? So, yan. And for the last part na tayo, malapit na tayo matapos. Okay. Mabilis lang discussion natin dito, no? Ito yung quickest discussion ata natin ever. Okay, so let's have the phase changes. Malapit na matapos. Okay, so phase changes, alam natin bakit uli nag-phase change. Number 1, energy. Number 2, intermolecular force. So intermolecular force, we can answer kung liquid, solid, or gas yan, depending on the strength. No? The stronger the bonds, the solid or liquid it becomes. No? Pero kapag weak yung bonds, gases yung ma-observe natin. Pero punta ulit tayo sa phase change. No? Kailan nagkaka-phase change? When you increase or decrease the temperature of your substance. If you increase the temperature, you give energy to the particles, making them, causing them to move. No? So the more chances na yung particles mag-move, then magta-transition yon from solid, liquid to gas. Pero kapag binabawasan mo ng energy yan, hihinto yung galaw nila. So they will transition from gas, liquid to solids. Na? So ito yung mga iba't ibang uri ng phase changes natin. So we can transition from solid to liquid, liquid to gas, or directly solid to gas. Na? Ayan yung mga tawag sa kanila. Solid to gas, sublimation, solid to liquid, melting, liquid to gas, vaporization, gas to liquid, condensation, liquid to solid, freezing, and gas to liquid, gas to solid deposition. No? So the higher the temperature is, the more likely you will form gases because the particles are so excited and they separate from one another. So kumakalat sila. Kaya ito yung nabubuo. Okay? Pero pag mababa yung temperature, kabaliktaran yung mangyayari. No? So the phases of matter varies. No? Nagbabago-bago yan depending on the temperature, depending on the pressure. So mas mabilis kumulo yung tubig sa Baguio kaysa dito. Bakit na? And ano yung explanation doon? So ganito lang yung idea. No? At different pressures and temperature, your matter can be compacted more or less compacted. No? So kapag more compacted sila, meaning mataas yung pressure, then most likely matagal bago siya kumulo. No? But in the higher altitude, for example, Baguio, mabilis kumulo daw yung mga tubig doon. I don't know. I've never been to Baguio. Hopefully sana nung summer kaso wala eh. COVID pa more, 'di ba? So nasa bahay lang tuloy ako. So 'yun. So mabilis daw kumulo daw yung tubig doon, sabi nila, no. Kasi mababa yung pressure. So the matter is not that compacted. So mabilis sila mag-transition to gas, no. So yun yung chemistry idea lang behind that, no. So the states of matter can be simplified, no, with phase diagrams, no. So makikita natin dito yung lahat ng uri ng matter natin, no. So makikita mo dito yung kailan siya mag-exist as solid, kailan siya mag-exist as liquid, kailan siya mag-exist as gas or vapor. Okay? So dito, makikita mo solid yung iyong particle. Dito makikita mo siya as liquid, dito as vapor. As you pass this line, that line, and this line, magkakaroon ka ng phase change. No? So the line between the solid and the liquid, we call that the melting curve. Dito nangyayari yung melting process. No? Dito nagme-melt yung ice to water, water liquid na. Dito naman, itong curve na to, the curve that separates liquid and the vapor, we call that the vaporization curve, wherein dyan nagkakaroon ng transition from liquid to gas. Okay, dyan nangyayari yung boiling. Ito naman, the line that separates solids and vapor, we call that the sublimation curve. Dyan nangyayari yung transition from solid to gas, no, without passing through sa liquid. So paano to ini-interpret, no? So you just select kung anong pressure gusto mo. Kunwari 1 atm. So at 0 degrees, you are specifically located on the melting curve. So dito nangyari yung freezing and melting point at the same time, no? Pero if you lower the temperature, pag binabaan mo pa yung temperature, ano mangyayari sa water mo? Magiging liquid siya. Ay, magiging solid siya, no? If you increase the temperature, magme-melt yan, then magiging liquid yan, no? Further increasing the temperature at 100 degrees Celsius, it will start to boil. Then magiging gas yan. Beyond that, no? Gas na siya. Okay? So, saan pa mapapansin natin sa phase diagram? Meron tayong makikita dito, no? Na intersection of the three curves, no? This curve, that curve. May curve tayo dito. Kung saan sila nagmi-meet, no? May point. We call that point the critical point. The critical point is the point where the three phases of matter can be observed. Makikita mo siya as solid, as liquid, and as gas. Okay? Mamaya may video tayo, no? Bago tayo magtapos ng class, papanoorin ko kayo ng video, no? So, asan na ba 'yan? Ito, mas maganda dito yung picture eh. Zoom ko lang. Yan. So, this is the triple point. At triple point, what can you observe is that three phases of matter can coexist. Pwede siya maging solid, pwede siya maging liquid, pwede siya maging gas, all at the same time, no? So, parang siya, trinity, no? So, ganon. Siya yung trinity ng phases, no, ng matter. Dito naman, mapapansin nyo, yung vaporization curve may ending. Yung melting curve, wala yung katapusan, no. Yung vaporization lang may ending, no. So, ang ending ng vaporization curve is called the critical point, no. This is the point where you can observe your liquid and gases as separate entities for the last time. So kumbaga ito na yung tipping point, no? Ito na yung pinakahuling point na makikita mo sila as separate, no? Makikita mo separate yung liquid, separate yung gas. Anything beyond that, you have your supercritical fluid, no? So ano meron sa supercritical fluid? Ano? Hindi mo na makikita yung difference between liquid and gas. Wala ka na makikitang difference diyan. So, magkahalo na sila. Okay? So, to further give you an idea kung ano yung itsura ng triple point and ng supercritical point, no? Or supercritical materials, papanoorin ko na lang kayo ng video, no? And dito nagtatapos yung lesson natin, no? So, I want you to watch these videos para magkaroon tayo ng idea, no? Teka lang. Triple point. Okay. So, itong papanoorin natin. Itong kay, mali. Itong kay Medilab HVL. No? So, kung gusto nyo panoorin uli, yan. Wait lang check ko lang kung naka-share yung audio. Okay, so yan. Naka-share na yung audio. So, panoorin nyo na lang po kung ano yung nangyayari at triple point and at critical point na. Okay, so that marks the end of our discussion. Pero manood muna tayo, okay? So, sige. So, panoorin po natin yung triple point na.
Imagine the same substance existing as a solid, a liquid and a gas, all at the same time. Sounds impossible, doesn't it? It's what's known as the triple point, and we are going to demonstrate it now. Any pure substance can exist in three phases. It can be a solid, a liquid or a gas. We can show these phases using a pressure-temperature diagram called a PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. There's a melting line between the solid and the liquid phase, a sublimation line between the solid and the gaseous phase, and the vaporization line between the liquid and the gaseous phase. The triple point is the location where all of these lines meet. It is specified by a certain pressure and temperature that is characteristic for each substance. If a pure substance is at these specified temperature and pressure values, all three phases will be present at the same time. One says that the three phases coexist. Pure water has a triple point temperature of 0.01 degrees Celsius and a triple point pressure of 611.5 Pascal. This is the same as about 0.6% of the usual atmospheric pressure. At this point, water will exist both as ice, as liquid, and as vapor. Let's see what this looks like in practice. For this experiment, we need a vacuum chamber which is connected to a vacuum pump. A combined pressure and temperature sensor is connected to the hose between chamber and pump. It is also connected to a PC via USB, and values of absolute pressure and temperature in degrees Celsius can be shown on the screen. Inside the chamber, we place a Petri dish with liquid water. After the chamber has been sealed, the pump is switched on. Both pressure and temperature start decreasing immediately. During evacuation, the liquid water starts to boil as the pressure drops to the saturation pressure at the given temperature. The glass beads reduce the splashing of water during boiling while the pressure decreases. They will also provide nucleation sites for the other two phases. While the pressure drops quite quickly, it takes longer for the temperature to approach values around 0.01 degrees Celsius. Unfortunately, our pressure sensor cannot measure below 1.2 kilopascal, but we will see later that the pressure is low enough as the water will be in all three phases. This can, however, take a few minutes. After some time, we see both formation of ice on the surface of the liquid water and that vapor bubbles appear in the liquid. We now have a situation where the water is boiling under a thick layer of ice. This is water at its triple point. All three phases coexist. The different phases are, however, not in equilibrium, as the amount of water in each of the phases changes with time. When we switch off the pump, the water will be stable at the triple point as long as the chamber manages to hold the necessary pressure and temperature conditions. Once we open the inlet valve and increase the pressure back to normal, we can see that the vapor bubbles disappear first. Small droplets on the glass bell eventually evaporate and the ice in the petri dish begins to melt. In a second run of the experiment, we also place a small beaker with sulfuric acid in the chamber. The acid attracts water molecules from the gas phase and helps to improve the vacuum. The steam produced during boiling eventually lifts the ice cap in a sudden motion. The triple point of water is used to define the Kelvin scale. Kelvin is the unit for absolute temperature and thermodynamics and one of the 7 base units in the International System of Units. At absolute pressure below the triple point, a substance cannot exist in its liquid phase. During condensation, for example, it will go directly from the vapor phase to the solid phase. This process is called deposition. We can observe this effect in nature. Fern frost can form on solid surfaces by the direct deposition of water molecules when the surrounding air is at temperatures below 0 degrees Celsius.
Ayun na. So, let's try to check kung ano yung nangyari sa video na. So, ano ba nangyari dyan? So, what can you see is that, di ba binaba niya yung pressure and temperature, no? So, as he turns down the pressure and the temperature, we are actually approaching the point at which the triple point can be observed, no? So, balik ulit tayo dito. So, balik tayo dito. May phase diagram ako ng water. So, for example, here, we have water, no? So, ginagawa niya kanina is that gumagawa siya ng vacuum in order to decrease the pressure, no? Tapos, may may cooler yun sa ilalim, no? Para bumaba yung temperature. Okay, so as the temperature and the pressure is decreased, what happens is that nagkakaroon ng conversion, no? Somewhere dito siya, nagkakaroon ng conversion from liquid to water vapor, then eventually papasok yun dito sa triple point na. So, ganun yung nangyari. Kaya kumulo, di ba? Pansin nyo kumulo kasi nag-pass through yun dito. So, eventually napunta dito. So, the triple point, napansin nyo na may ice, may liquid, and may water vapor na nag-exist all at once, no? So, kagaya dito, no?
The surface of the liquid water
Ayan, no?
and that vapor bubbles appear in the liquid.
So, yan, may ice ka.
We now have a situation where the water is boiling under a thick layer of ice.
So, ice, may bubbles, and may liquid
This
sa
is water at
ilalim.
its triple point. All three phases coexist. The different phases are, however, not in equilibrium, as the amount of water in each of the phases changes with time.
Okay, so yun yung nangyayari dito, no? So, yun lang. Yun yung triple point na. So the next one that we're going to watch is the critical point na. This will be the last video. Okay? So panoorin po muna natin ang critical point.
Every substance has a critical temperature and a critical pressure. When a substance is subjected to temperature and pressure that both exceed these critical values, it enters what is called a supercritical state. Any pure substance can exist in three phases, can be a solid, a liquid, or a gas. We can show these phases using a temperature-pressure diagram called the PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. We have the sublimation line, which divides the solid and the vapor phase. The sublimation line ends at the triple point, which is the point where all three phases coexist. There is a melting line between the solid and the liquid phase, and the vaporization line between the liquid and the gaseous phase. The vaporization line ends in the critical point. The temperature on this point is called the critical temperature and usually gets designated the symbol TCR. The critical pressure has the symbol PCR. These values, together with the critical density, are characteristic for each substance. With pressure and temperature that exceed the critical values, the substance will become supercritical and the differences between the liquid and the gas phase disappear. Let's see how this works in practice. For this experiment, we made our own pressure tank. It has a thermometer, a pressure meter, and a pressure relief valve. We also have some dry ice, which is carbon dioxide in the solid phase, a heating plate, and a heating base. We put some dry ice into the tank and seal the tank. As the pressure tank is completely sealed, the pressure builds. The dry ice starts at a low temperature, but with the rising pressure, it soon turns into a saturated liquid vapor mixture at about 40 bar and 5 degrees Celsius. By applying heat to the tank, we increase the pressure and temperature towards the critical point at constant volume. CO2 has a critical temperature of 31.25 degrees Celsius and a critical absolute pressure of 73.9 bar. So we want to heat up the carbon dioxide to its critical temperature, and because the volume of the tank is constant, we can also build up the pressure. As the pressure and temperature reach the critical point, the distinction between the liquid and gaseous carbon dioxide becomes less visible and eventually disappears. The phase boundary between the liquid and the gas vanishes. The CO2 is now in a supercritical state. To return to a state below the critical point, we will cool the carbon dioxide and make it reappear in the saturated liquid vapor mixture. By removing the heating plate and then adding dry ice on the aluminum cylinder, we can observe that the liquid vapor interface suddenly reappears as the temperature decreases. We have returned to the saturated liquid vapor mixture. Supercritical CO2 is used in a variety of applications, for example, to remove caffeine from coffee beans.
Ayun. So, okay. So, ano napansin natin, no? So, this is the point before the before the liquid becomes supercritical, no? So, you can see here the separation between the liquid and the gaseous phase. Now, however, soon as you go beyond sa critical point, ano napansin ninyo? So, saan na yan?
Liquid and gaseous carbon dioxide becomes less visible and eventually disappears.
So, yan. So, makikita nyo, nawawala yung boundary, then eventually, nag-mix na sila.
The phase boundary between the liquid and the gas vanishes.
Ayun. So, di ba kanina may line dyan, ngayon wala na. No? So, that's the supercritical fluid. No? So, saan po ginagamit yung mga supercritical fluid? Saan ginagamit yung mga triple point? No? So, most of the time sa research. No? And by the way, ito palang ginawa niya. No? So, we started here sa ano na to? Sa temperature na to, no? So, we started here. Siguro dito, no? Somewhere here. Ano ba kaya? Siguro 25 degrees Celsius yan. So, dito tayo nag-start at 1 atmosphere. Then, ano ginawa, no? So, ang ginawa niya, in-increase niya yung pressure. So, by increasing the pressure, umakyat siya dito. Then, nakita niya, di ba, yung dry ice, bigla naging liquid. So, yan. So, ganun yung nangyari. So, nandito siya sa 25 degrees Celsius, kunwari, yun yung temperature ng lab niya. So, in-increase niya yung pressure until mag-melt. Mag-condense ang dry ice na. Okay, so yan. So, naging liquid na yung dry ice, then eventually, na-reach niya yung supercritical point na. So, ganun lang ginawa niya. Adjust mo lang yung temperature, adjust mo lang yung pressure, then mapupunta ka doon. Okay, so ganun din yung ginawa sa water na. So, start tayo dito, binaba yung pressure, binaba yung temperature. So, we ended up with the critical point. Saan po sila ginagamit, no? So, usually, they are used in research, no? Sa mga paggawa ng superconductors, no? Mga semiconductors research, no? So, yun. So, sila ay ginagamit para sa paggawa ng mga super materials that will eventually help us in harnessing more energy sa environment, no? Not only lang, hindi lang naman limited yan sa energy, no? So, ginagamit din yung mga ganyang idea for creating good materials, no? Mga matitibay na materials to help our technology. And, yun lang. Manufacturing as well, no? Sabi nga niya, ginagamit daw yung supercritical na carbon dioxide in extracting caffeine, no? So, sa mga kape-kape, no? So anyway, so that's the end of our discussion, no? So that's the end of the lesson about intermolecular forces, solids, and liquids, no? So kumbaga, puro concept lang tayo, no? So I suggest you to read all the materials here. So yan, basahin nyo na lang, no? So itong mga part na to, no? Itong part na yan, siniskip ko na yan. Yung part na yan, niskip ko yan. Bakit, no? Calculation na yan. So, gusto ko medyo magpahinga tayo sa calculation. Although madali lang yan, though it will take more time. No? And so, I mean, papagurin ko na kasi kayo ng calculation after this meeting. No? So, mga susunod na linggo, more on calculations talaga tayo. So, let's have a short break muna sa calculation. Okay? So, yun lang. So, with quiz, with chapter 5 already discussed, no? So, since tapos na natin yan, I will open itong quiz na to, no? So, open ko na siya para makapag-take na kayo, no? So, open ko to mamaya, no? So, mag-open na ako ng quiz 5 later. Itong Lec and Lab, no? So, again, this is 2 attempts, no? Dalawang attempts yan. Gagawin kong dalawang attempt yan. So, galingan nyo na lang pa, no? So, yan. And again, yung quiz 4 nyo, ha? Yung quiz 4, Lec and Lab. So, pwede na kayo magsagot niyan, no? That's until October 11. Yung quiz 5, gagawin ko dito until ano siya. Kasi October 11 sa Sunday, no? Siguro gagawin ko na lang siyang October 17, no? Sa Saturday next week naman to. Okay? So, ano po gagawin natin sa Sabado? Kasi tapos na tayo sa chapter 5, no? Today. So, sa Sabado, we will proceed with the module 6, no? Stoichiometry na tayo. Okay? Yun. So, 6 na tayo sa Sabado, stoichiometry. Medyo mahaba kasi ito no? Para mas marami tayong time to study. So, yan lang naman. So, good luck po. And stay safe as always. No? So, again, if you want to review, punta lang kayo dito sa ating course card. Punta lang kayo dito sa Canvas. Dito sa announcements. Recorded class discussions. Andyan po lahat ng video. Hanapin nyo lang yung PSY. Yan, Sci, Chapter 4, Day 1, Chapter 2, Chapter 4, Day 2. Yan, so pwede nyo po panoorin yung mga yan, ha? Kung gusto nyo makinood ng iba kong klase, go lang, no? So, basta yan. Available po lahat ng lessons natin dito sa YouTube naman. So, yan. Do you have any questions po? Or okay na tayo?
Wala naman po, sir.
Okay, so basta yan na, refine yung concept na lang, no? Kapag nakalimutan yung bonding concept, manood na lang kayo ng chapter 4 ulit, no? So dito naman yung chapter 4, no? Ayan, hanapin nyo na lang, ayan, chapter 4. So panoorin nyo na lang po ulit, no? Para ma-refresh. Then, etong lesson na to, upload ko to mamaya, no? Pagkatapos ng class na to. Okay, so with that, I'll see you again on Saturday. We will discuss stoichiometry on Saturday, na. So, ayan. So, bye-bye na po. And I'll see you again next time. So, bye-bye and ingat parate. No? Sige.
Kaya din po